All right, so I'm going to go over these problems from Unit 6. Remember, if you don't have your Unit 6 review sheet done, you cannot retake the Unit 6 test. So here we go. So number 1 is an adding problem, just like also number 2 is subtracting. It's the same idea. We need a common denominator. So number 1, these denominators are totally different. So my common denominator is going to be x minus 5 and x plus 2. I'm just going to put those two things together to be my common denominator. So I have addition up top. My 2x needs to receive the x plus 2 because that's what I'm giving to the denominator. I only had x minus 5 before, and I've given it this, so I have to give it to the top. The 3 needs to receive the x minus 5. So, like I told you in class, this is a little bit like cross-multiplying in a way, even though it's not. It's kind of like you're giving this to him and this to him, and then that's your new numerator. So I like to go and kind of figure that out on the side. 2x times x right here, and 2x times 2. So that would be that would be 2x squared plus 4x, and then the same here, plus 3x minus 15. So that way when I go to my answer, I have 2x squared on top plus 7x minus 15. So that's my final answer, 2x squared plus 7x minus 15. Now you might be thinking to yourself like, oh, am I supposed to factor the top again? Because now I have something else that looks like I can factor it. Well, you should, but the only reason that you really care is if it factors into something that cancels on the bottom. So when I factor that, 2x and x, and 15, if I use 5 and 3, a 5 here and a 3 there, I'll get 10 and 3, so make a positive 10 and a minus 3, it does factor. But it's not important to me because nothing that it factors into matches anything on the bottom. And so if that x plus 5 had been an x minus 5, then I might have cared and I would have canceled out. But for right now, this is it. And on your test, you're just going to be done here with the thing that I circled. I'm not going to give any ones that are like super difficult. All right, so the next one, number 2. You're looking at x squared minus 16. You cannot know what to do here until you factor that. X squared minus 16 is x plus 4 and x minus 4 when you factor. So when I decide for my common denominator, I'm going to go ahead and say that I need both x plus 4 and x minus 4. They each have x plus 4 one time, so I can just put it there one time and they can share it. All right, so the 5 needs nothing. The 5 has everything that it had before. The minus 2 needs, let me see what's going on here. The minus 2 needs to get x minus 4. All right, so like before, I'm going to work this out. I got 5 minus 2x, and then here it turns into a plus 8. So just be careful with those double negatives. So my final answer would be negative 2x plus 13 over x plus 4 and x minus 4. All right, and that can be finished. 2x plus 13 doesn't factor, and you can put 13 minus 2x if you really want to also. All right, for number 3. Number 3, remember, basically everything on this test needs to be factored for you to see what's going on. So in number 3, when I'm looking at this, there's no flipping around because it's just multiplication. So I got x plus 2. That's the only thing that I'm not going to change about this problem. Underneath, I have 4x squared minus 7x minus 15. I'm going to fix that. On top over here, I have perfect squares right there. So I'm going to split that into 5 plus 4x. It's 5 minus 4x. It's backwards. Just leave it backwards and factor it that way. All right. So on the bottom, though, the 6, 15, and 6 right here, this guy. This is the most troublesome one because those all divide by 3. So you have to pull a 3 out first and then leave yourself with 2x squared plus 5x plus 2. And then you can leave the 3 sitting there and factor what's left. So I'm going to have 2x and x. The only way to make 2 on the end is to put a 2 and a 1. I have to put the 2 in the back because I can't put it here, so there's a 1 there. So 4 and 1 make 5 if I go ahead and put everything plus. All right, now factoring the 4x squared minus 7x minus 15 over here, that's a little bit troublesome. But if I look around, the top of my problem right here, I got some like, whoops, wrong one, sorry. Hang on a second. Oh, this one. Undo. All right, there we go. If I look around this problem right here, I do have like some stuff with like 4x in it. And so I think I'm about to get a 4x here if I would just do 4x and x. So I can use that for a clue because I could have put 2x and 2x and tried that, but I would have been here a while. So 4x, if I go ahead and put the 3 here and the 5 there, you see I'm getting 12x and 5x. That makes -7 if I do +5, -12. So plus here, minus there. All right, so let's take a look. When I go to my canceling, I see 4x plus 5 and 5 plus 4x. These are exactly the same thing. All right, I see x plus 2, and that's it. So that wasn't very satisfying for all that work that I had to do. All right, so on top, on the numerator, I have 5 minus 4x. In the denominator, I have a 3, I have a 2x plus 1, and x minus 3. So I'm finished. All right. All right, for number 4, there will be a problem looking like this on your test. Remember, this is just division. So with division, the first fraction stays the same, 4 plus x, and you can make that x plus 4 if you want, and 28, x 12. Well, the second fraction flips around and you change to multiplication. So that means the bottom comes up, 7x to the third is on top, and x plus 4 is on the bottom. So realize that these two right here, these two pieces are exactly the same thing. Somebody just wrote them opposite ways. But if this had been 4 minus x and x minus 4, when I cancel those, I would have put a negative sign. But I don't have to do that in this case. So no negatives. So I can swipe these two away. I have 7 on top and 28 on bottom. So 7 divides by 7 one time, and 7 goes in here 4 times. And then I have x3 and x12. Well, remember, you subtract your exponents. So 3 minus 12 is -9. So that means my final answer has 9 x's on the bottom. So x to the 9th on the bottom. And there's no x's up top, and there's a 1 sitting there, and then I have a 4. So the number's reduced to 1/4, and there's 9 x's left on the bottom. So that's my final answer. All right, moving on to number 5. Number 5 is an equation, and also number 6. Now, number 6 is kind of the easier scenario. You have just two fractions equal to each other, so you just cross multiply. You do 2x times x minus 2, and then you do 5 times 4x. Now, of course, 5 times 4x is 20x. You can just write that. So I get 20x, and this multiplies out, be very careful, 2x squared minus 4x. If you perhaps forget that x right there, it's going to screw up your whole problem, a whole different answer. So I'm going to pull the 20 over to be with everyone else. I'm going to subtract 20x. So I get 2x squared minus 24x. So notice this is I'm going to have to factor, but it's a different style of factoring. I'm pulling out the greatest common factor. There's no number on the end. You see how like this has a 15 on the end, so I know I have to write 2 parentheses? Well, this doesn't. I'm just going to pull out a 2x, and leaves me with x minus 12. I divide everything by 2 and also x. So that means I have 2 answers. For the 2x, 2 times 0 is 0, so one of my answers for x is going to be 0. And for this part here, 12 minus 12 is 0, so the other answer is 12, makes it 0. So I make one last check, look at my denominators. Here is my denominators. Do I have a problem with any of these answers? Well, the only thing I would have had a problem with here was having a 2 minus 2. I don't have 2 as an answer, so I'm going to keep both of these things. There are no extraneous solutions. All right, with number 5, if I'm looking to decide on my extraneous solutions first, I would never accept 0, because 4 times 0 is 0. So if I get 0 as an answer, it's going to be no good. All right, but let's take a look around. So here I need a common denominator on both sides. I have more than 2 fractions. I can't just cross multiply. So if I'm looking around, the 4s and the 3s, 4 and 3 both goes into 12. And also I need an x, so that's my decision. I need a 12 and an x. Over here, I need a 12x. So on the right side, the 5/4, that's an easy fix. 4 times 3x is 12x, so I have to multiply the 5 by 3x. So 5 times 3x, I get a 15x here. All right, on the other side, this 4x here, I multiplied it by 3 to get 12x on the bottom. So I'm going to multiply the top by 3 as well. So 3 times x minus 3. It's almost exactly like problems 1 and 2, like you're just combining like combining the fractions, getting a common denominator. So this 3x here, to change 3x to 12x, this new one here, I need to multiply by 4. So I'm going to multiply the top by 4 as well. So 4 times 4x plus 1. All right, so now that I look at this fraction overall, I have a top over 12x equals another top over 12x. The 12x is already matched, so I can kind of forget about them. All I need to do to solve this and get the answer is make 3 times x minus 3 plus 4 times 4x plus 1 equal 15x. Now, don't forget your old stuff. I mean, this is just a regular problem to solve. I'm going to multiply this out. 3x minus 9 plus 16x plus 4 equals 15x. All right, it's just a normal problem. Okay, so on the left side, I'm going to clean that up. I get 19x minus 5 equals 15x. All right, it might seem worse, but I'm going to have to subtract 19x because in a normal problem, there's no squares. All I have to do is get x's on one side and leave the numbers on the other. So that's gone. So I have negative 5 equals negative 4x. So my answer is 5 over 4. Right? And 5 over 4 was not 0 that we talked about earlier, so I'm good. Keep it. All right, with number 7, the pressure. So I got pressure varies jointly with the depth and the density. So remember, joint variation is just y equals k, x, and z. I am going to use these new letters, so I'm going to write P equals K, little d, big D. And that's it. No squares, nothing. And number 8, it says the resistance varies directly with the length. So there's one part. So R equals KL, but then it says it also varies inversely as the square of the diameter. So inversely means it goes underneath, and I'll put d squared. Now, on your test, there might be a question like this where you write the equation, but there will also be problems where you have to plug in numbers for all these letters and then figure out what k is, like we did in class, and also on your quiz that you took in the middle of the unit. Okay, and then you have to use that k value to find a new answer. All right, and number 9. Number 9, we did a warm-up in class this week, and we talked about how if you want the end behavior of a graph, the end behavior, if I just kind of draw one over here, just real quick. It's not particularly this graph right here, but if I draw a graph and you know I have an asymptote here at like 2, and I have an asymptote here at like 4, if I have a graph that kind of sits inside those asymptotes, the end behavior is asking you what's going on at the end of the graph. At the end of the graph as you go to infinity and negative infinity. So you can see that on my graph, even though it's kind of drawn crappy, that this graph, as you go towards negative infinity, it's climbing up and kind of staying right at 2. It's right below 2, but it's like enough there that we can say it's at positive 2. And then this one is coming down and going across, and it's creeping down towards 2 as well. So the end behavior basically is the horizontal asymptote. So if you look at the horizontal asymptote of your thing here, of your equation here, you got y equals 8 over 2 because the x squareds match, so that's 4. So I would pick letter C. The end behavior is the horizontal asymptote. All right, moving on to back here. All right, identify the horizontal and vertical asymptotes. Well, horizontal asymptote, I'm going to compare these. They match, so I'm going to steal the 5 and the 1. So I'd say y equals 5. So this guy right here. Vertical asymptote, I look at the bottom. So what makes the bottom 0? That's going to create an asymptote. So that's x equals 4. So this guy here. All right, number 11. Oh boy. All right, we got a lot going on number 11. It's a fraction inside of a fraction. Fractions inside fraction, and then I got to factor everything. Ay, ay, ay. All right, so here we go. So I'm going to have 2 parts. Okay, 9x squared minus 1 is going to go right up top here, but I'm going to factor it as I write it. So I'm going to write perfect squares, 3x plus 1, and 3x minus 1. All right, this guy is kind of troublesome. You notice how it has a negative in front of the x squared. I can't factor with a negative in front of x squared. So I'm going to pull the negative out and just write 5x squared plus 11x plus 2. So basically when you pull a negative out, it changes all the signs. Negatives become positives and positive become negative. So they were all negative, so they all became positive. So when I go to factor that, I have a negative sign, and I'm going to factor. I got 5x and x. I need to make 2 in the back, so I think I'll put 2 here and 1 there because I'm getting 10 and 1 to make 11, so both plus. All right, now this fraction right here, that's going to flip over, and the 10x plus 4 is going to come up to the top right here. So 10x plus 4, I can take a divide out of 2. So I'm going to pull out a 2, which leaves me 5x plus 2. And look at that. Oh, I don't have a match. Dang it, I thought I did. All right, so now this part, this guy, he's down here, but he's going to be quite annoying because he is all perfect cubes. So I have a little piece, a binomial, and a trinomial. So 3 times 3 times 3 makes 27, so I'll put 3x. 1 times 1 times 1 makes 1, so I'll put a 1. Then remember I do square and multiply square. So take 3x and square it, and you get 9x squared. Multiply 3x and 1 together, that's 3x, and square the 1 on the end, that's 1. Then you do your SOAP, same sign, opposite sign, always positive. Now, the lucky part here, this piece here will never factor again. You're finished with it. If you try to factor it or do quadratic formula, it's just imaginary answers, so don't even worry about it. All right, let's see what happened here. 3x plus 1, are you kidding me? Oh my god, that's the only thing that canceled? Let me see. Let me make sure I did everything right. Oh, how horrible. All right, well, there it is. So usually I would make more things cancel. But after all that factoring work, this is my answer. 2, 3x minus 1, and 5x plus 2. I think I messed up. I should have made more stuff cancel. Negative 5x plus 1, x plus 2, and 9x squared minus 3x plus 1. So that was just like a factoring test. All right, here we go. So number 12. Number 12, more factoring. All right, so when I factor number 12, what's causing me a problem first is this guy up here. They all divide by 2. So if I snag out a 2, that would be x squared minus 5x plus 6. So that's much better for me to factor. So 2, I got to multiply to 6. So x and 3, x and 2. I got to make negative 5, so I'll put both negatives, and then it makes a positive 6 in the end. On the bottom, same scenario, but it's going to be x plus 3 and x minus 2. So when I simplify this, I notice that the x minus 2's are going to go away. Well, that's going to start creating a hole at 2. So when I write my domain, I'm going to say, hey, use any number you want, but don't use 2 and don't use negative 3. Well, the negative 3 stays in my problem because look at what I have left. If I write what I have left, I have 2 and x minus 3 over x plus 3. This is now my function. So x plus 3 is still the place where the asymptote is going to be. So the asymptote is still going to be at negative 3, but the other one, the 2, went on to become a hole. Well, if I want to get the answer for the hole, I plug 2 into this problem. So y would be 2 times 2 minus 3 over 2 plus 3. So that's 2 times negative 1 over 5, so negative 2/5. So to find where the hole is, you plug the x value into the leftover problem. So that'd be negative 2/5. And so if I want to put that on my graph, 2 and negative 2/5, it'd be like right in here somewhere. There's going to be a hole. All right, horizontal asymptote. You can look anywhere. You can look at the thing that we reduced. So you can look right here, or you can just look back at the beginning. 2x squared and x squared, that means they match. So I'm going to say y equals 2. All right, so on your test and on your review sheet, you got to draw these things. X equals negative 3. Y equals 2. There's your asymptotes, and your graph fits into there. So on your test, you're also going to have to find your x and y intercepts. So the x-intercept is when the y value equals 0. So I want to know when this equation over here equals 0. Well, it equals 0 when the top equals 0. So it looks like 3 is going to be it. So 3 comma 0. The y-intercept is when the x value equals 0. So all I have to do, I can just go back to my main equation. If all the x's are zeros, that's gone, that's gone, that's gone, that's gone. Look at my two numbers left, 12 and negative 6. 12 over negative 6 makes negative 2. All right, so here we go. I'm going to mark that 0, negative 2, 3, 0 right there. So we're going to check, but I bet you this graph comes up here like that. And then probably comes around there like that. So I have it on my calculator already. We'll just check it. Okay, and there it is. So matches up pretty good. All right, and I typed it into my y equals the original problem, and then I graphed it. Okay, I don't know about you, but I'm kind of tired here. All right, here we go. Number 13. So number 13, this is a common denominator problem. Just like mush this all together. I notice I'm going to pick this for my common denominator because that is a combination of these two things. So my common denominator is going to be x plus 1 and x minus 1. All right, so looking along here, the only thing that's not going to change about the top is the 4. The 4 in the back, he's not going to do anything because the bottom is staying the same. The 3 needs to get an x minus 1, and the x needs to get an x plus 1 to be fair. Okay, so all you got to do is figure out the top. This part here, 3x minus 3. Then here, x squared plus x. And I got minus 4. So I'll clean that up. Let's see. I got x squared plus 4x minus 7. And nothing that multiplies with 7 makes 4, so I'm all set. I don't have to even try to factor. All right, so that wasn't too hard. Oh, and it's multiple choice, so it is letter D. All right, so number 14 and 15. So number 15, you can cross multiply, so why don't we just get that out of the way real quick. I have x times x plus 2. And then I have 2 times 16 minus x. So I'd recommend writing this out because you need to be careful. X times x is x squared. X times 2 is plus 2x. If you forget anything, it's going to cause a fail. So here times here is 32. Here times here is negative 2x. All right, so I need to bring everything over to the left because that's where the x squared is positive. So I get x squared. I'm going to add 2x. So I get plus 4x. And 32 has nothing to go with, so I'm just going to move him over. He changes to a negative 32, and then I got nothing over here. All right, so let's factor. What multiplies with 32 and makes 4? So I think I can do 8 times 4. Plus 8 minus 4 makes negative or positive 4x in the middle. So my answers are negative 8 and 4. So when I look at that, those are fine with me. I was not going to accept 16 and negative 2. So x could not be 16 or negative 2, but I did not get those answers, so these are fine. All right, over here. So when I look at this problem, I see x plus 9 on the bottom, I see an x by itself, and I see a 5 with an x. So when I decide my common denominator, I'm going to put a 5, an x, and an x plus 9, all 3 of those pieces. So they're all, 3 separate pieces, the 5, the x plus 9. Even though you see this 5x together here, you can they're just multiplied together, sitting together. So when I look at this fraction here, I see that it has a 5x already. It didn't have the x plus 9. So 3 is going to get x plus 9. So notice, if I would cancel this back, I would have what I started with. That's always what you want to happen. But you don't want to cancel it because you're trying to make a problem. Over here, the 4. So 4 has the x plus 9. He doesn't have 5x, so times 5x plus the 2. Well, the 2 has the x, but he doesn't have the 5 and the x plus 9. So he has this, but not the others. So I need to multiply him by 5 and also x plus 9. All right, so right now, I'm going to just drop the denominators. I don't need them anymore. So as I do that, I'm going to bring down the numerator. So 4 times 5x is 20x. This right here is 10. So 10 times x is plus 10x. 10 times 9 is 90. And over here, I get 3x plus 27. So I look across there, I have no squares. This is a nice little easy Algebra 1 problem to solve. So I got 30x plus 90 equals 3x plus 27. I'm going to subtract 3x over here and put 27x. I'm going to subtract 90 because I moved my 3x. Subtracting 90, so 27 minus 90. 63, negative 63. Okay. Yeah, 70. Yeah, that's right. So my answer is negative 63 over 27. But these both divide by 3, so I'd more officially say, actually they both divide by 9. So that's going to be a 3, and that's going to be a 7 on top, negative. So negative 7/3 is your best answer. All right, so that is it. Study, study, study. Bye-bye.